Hey everyone, welcome to Tutoring. Hope you're having a great day. Today we will be doing question 19 from chapter 9D. So that's your difference of rates chapter. I reckon 9A, B, and C are fairly straightforward. So if you've done methods already, it's pretty standard. But 9D is something very new, okay? So that's your difference of rates. Okay, so the reason why I picked this question is because it's very different to your typical difference of rates question, and that's because they give you some percentage. They don't give you in terms of mass or kilograms. They give you, like they don't give you like salt or sugar. They actually give you some kind of other solution inside your tank. Okay, so I just want to tackle this question because there is a bit of confusion regarding this question. Right, so let's get into the question. Question 19. A laboratory tank contains 100 liters of a 20% serum solution. In example, 20% of the contents is pure serum and 80% is distilled water. So it's pretty much still like a concentration volume question. It's just now you don't have it in terms of mass, you have it in terms of percentage. So it's actually volume as well. So it's volume over volume. If you've done chemistry, you should know what that is. Anyway, whenever you're doing these questions, like I said, you should always, or like I've mentioned in the topic video, always draw your diagram, okay? So you've got a tank, doesn't really matter what you have, what shape the tank is, because we're not really doing related rates question, but in the exam you actually might. But anyway, this is a tank, pretty standard. Our volume is 100 liters in there. Now, typically I would put the mass. So what kind of mass, or like how much kilograms of salt or sugar do I have? But in this case, it's not really mass. It's actually serum solution. And they said 20% serum solution. What that means is you actually have 20 liter of the serum in your tank. So the whole volume is 100 liters. But you've got 20 liters of serum, and this 100 here is just a total. So you actually have 80 liters just pure water, distilled water, and then 20 liters of serum. But this 100 just means total, okay? Not pure water. It's just a total volume in this tank. Right, so that's how you would go about sorting out your initial conditions. Let's keep reading. A 10% serum solution is then pumped in at the rate of 2 liters per minute. Well, okay, so going inside dV dt, so that's your rate of volume inflow volume, it's 2 liters per minute, and we know the serum solution is 10%, so that means your concentration, V over V, so dm in this case is actually x, so let's use the x dV. They said 10%, right? 10% of 2 liters, so that's technically just 0.1, okay? We want 10%, we're going to multiply it later by 2 liters to find what the actual serum is, but yeah, dx dV equals 0.1 because that's 10%. Okay, now the outflow, let's keep reading, and an amount of the solution current in the tank is drawn off at the same rate. Well, okay, it's drawn off at the same rate, meaning the VDT outflow is also 2 liters per minute. Now you also want to find your dxdv, which is the concentration outflow. Now how would you go about this? Well, I've also made a topic video on how to go about this, like these kind of difference of rates. So make sure you check that out if you don't understand what's happening here. But the xdv is always, like we said, concentration over volume, right? Mass over volume, right? To get your concentration. So mass is always x at any time t. It's always x. It doesn't matter what it is. That's what the definition of x is. See, where x liters is the amount of pure serum. Yep. So that's pretty much the mass. Technically, your mass. It's not really called mass, but yeah, it's pretty much the amount of serum you have, and then over the volume, the total volume at any time. So you start off with 100, that's any time, and then you, of course, at any time, you're going to have some inflow, which is 2 over here, but then you also have outflow, which also happens to be 2. And then you multiply that by t because, of course, at any time t, so maybe after a minute, if your inflow was 3 and then your outflow was 2, then you'd have 1 extra liter. But in this case, because they're the same inflow and outflow, because you have the same inflow and outflow, they just cancel each other out, so that's pretty convenient. Your dxdv is just x over 100, okay? So that's your diagram. Make sure you draw your diagram. If you can draw your diagram, guys, you've pretty much done 50% of the question already, okay? So let's have a go at the question. A, set up a differential equation to show the relation between x and t, where x liters, yep, that's fine. We just basically need to find dx dt, that's our differential equation. How would you find dx dt? Well, that is the xdt, so the xdt here just means the net inflow and outflow, okay? So the xdt inflow minus the xdt outflow. Well, what is inflow? Well, inflow is just dv dt times dx dv. So if you want to find your mass, it's your concentration times your volume, right? So, you know, C equals to m over v. If you want to find mass, that is C times v. So that's pretty much what we're doing here. So you have 2 multiplied by 0.1, and then your outflow, same thing. It's 2 multiplied by x over 100. So you end up with 2 x over 100 when we multiply them. So let's simplify this a little bit. 0.1 is 1 over 10, so 2 times 1 on 10, that's 1 on 5. And then minus x over 50 after you simplify. And then, of course, this gives us, if we want to bring them to the same common denominator, 5 times 10 to give us 50, so that's 1 times 10 as well. So that's 10 minus x over 50. So that's your dx dt, your differential equation, your net flow, okay? So that's part A. Right, now let's look at part B. So what do they ask here? How long will it take for there to be an 18% solution in a tank? Assume that at all times the content of a tank form a uniform solution. Okay, so this is always the case. Don't worry about this second part right here. In the special course, the content of the tank, I mean the solution is always uniform, meaning this amount of salt at this part right here is the same over everywhere. Okay, the concentration is the mass, or you know, your serum is spread out evenly, so that you know your outflow is not taking too much. It's not like your serum's all here, so there's a higher concentration outflow. That's just what it means. But yeah, in the special course, don't worry, it's always evenly distributed no matter what. Right, how would you find, so how long will it take for there to be an 18% solution in the tank? There's actually 2 ways of doing this. I'm going to show you the shortcut, but I'll also give you an idea of what the the traditional way of doing this is. So the traditional way is obviously you solve for x in terms of t from this differential equation. We've done that in one of the topic tutorial video before. Or you've probably seen already from your textbook. But yeah, it's just anti-diff, solve for x in terms of t, and then you get, you know, x as a function of t, right? F of t, and then you sub in x equals, and then you let x equals to 18, because 18% solution means you have 18 liters in your 100 liter solution. That's it, in your 100 liter tank, okay? So it just means your x, the amount of serum in liters in your tank, is 18, so you let x equals 18, and then obviously you let it equals ft, and then you solve for time. So time will be whatever that is. So that's the traditional way. Yeah, and that's an alright way to do it, but there's an actual shortcut to doing this question, okay? And that is solving differential equations using definite integrals. I've made a topic video on this as well, so if you want to check that out, I'll leave in the link below, and maybe the pop-up above as well. So check that out if you want to find how this formula came about. But pretty much, I'll go through this with you. So dx dt equals to 10 minus x on 50. We want to find, well, technically x in terms of t, right? So let's get our differential equation so that it matches well first. dt dx, we flip it. It's equals to 50 over 10 minus x. And then t equals to the antiderivative of 50, 10 minus x dx. Okay, and here's where the shortcut comes in. Instead of anti-deriving it here, and then you know you have your plus c, and then solving for all of that, and then later on solving 18, what you can do is, because this question is not asking you to solve for, you know, like find x in terms of time, find the solution. It's just saying how long will it take, so find t at this specific time when x equals to 18. So what you can do here, here's the shortcut, okay? So the formula for definite integrals, using definite integrals to solving differential equation, is on your upper terminal, it's the value that they give you, that you the value that was given to you that you want to find. So what I mean here is the 18% solution, right? When x equals to 18, what is t equals to? So that's the x value right there, okay? So that's what you want. So that's on the upper terminal. And then on your lower terminal, that's the time. So in this case, on your lower terminal is a solution at the start. So the given condition. Your given condition is 20 liter, right? So you put 20. You started off at 20, and then on the over here on the after your integral, you plus a 0. That means you plus the time. So this is the time at the start. So these two are interconnected. So this is essentially t0. This is essentially x0, and this is what you want to find. That's the x1, and then that's the t1. That's the one you want to find, the t1. Okay. So It pretty much works for every integrals that's using the definite integrals, okay? So right here, let's solve for this. If you chuck this inside your calculator, because this is obviously an application question, you can do it using your calculator. If you chuck inside your calculator, your final answer should be 11.16 minutes, okay? So if you actually type this in your calculator, that's what you do. See, this is actually like a 3-step process, whereas if opposed to doing the traditional way, it's going to be a lot longer, okay? So you can only use the definite integral formula for questions that ask you for the specific, t value or the y value or specific something when given like at this time or at this this solution, this amount, okay? So that's only when you're given a point that you want to find. If they ask you to find the equation or the solution, then you would have to use the traditional way, okay? So that's pretty much it for question 19. What I wanted to go through was especially that part B, but hopefully you guys found this video useful and you learned some new tips and tricks in here. Aside from that, guys, thank you for watching and I'll see you in the next video.